You guys tell me that I sound like a robot. This is what a robot sounds like. I do not sound like this. Okay, this is 17.4 stem and leaf plots and histograms. You need to set up your Cornell notes like this. It's probably April 6th when you're doing this video. Whatever day it is, you put that date there. And then not very many questions are being written over here. In fact, when I walk around, I never see questions over here. You guys, I know that there's bits and pieces of the video that you do not understand, and there are skills and stuff that you just don't get. You need to be making notes of those. Write a question to me. If you're at home watching the video, write it down. If you're in class, write it down, and that way you can ask it, or maybe your question will get answered in the video, but you need to be writing them down. A lot of you are really excited about stem and leaf plots because you've seen them around and you want to understand them. So here we go. I'm going to delete this so that we can start our other notes. Okay. Good night. Every time I do a video, I have to remember how to delete. Alright, so it says that stem and leaf plots, of course, are used to display a bunch of data. We've been talking about how where we see big groups of numbers like grades and ages and stuff, and there's different ways to organize them. So on a stem and leaf plot, you have, let's say you have this group of numbers. Okay, what's the smallest number? Looks like it is 19. And then the biggest number is 44. Okay, so you have numbers in the 10s, 20s, 30s, and 40s. And that is how your stem and leaf plot is organized. Kind of like, what does that look like? Cornell notes. Over here you have your stems. Here you have your leaves. Okay, set this up. You take your smallest number, which is 19, and you write a 1 on this side and a 9 on this side. This row right here is for your teens. Okay, if we had numbers that were smaller than the teens, we would put them above that. We'd have a 0 in the stem. Okay, now next will be the 20s. So all the 20s are going to go on this row. And we only have to write the 2 once, and all of our ones places will go after that in order. So let's find all of our 20s. We have 29, 25, 23, 29. So we're just going to put those in order. What was that one? 29. Okay. Okay, so 20, and then we'll put my ones places. 23, 25, 29, and 29. Okay, so right now I can see that there's more numbers in the 20s than in the 10s. Now I can feel you thinking, oh, I get it. Okay, let's find the next group. It'll be the 30s. Okay, so everything will start with a 3. We just write the 3 one time. This saves the energy, not having to write so much. All right, so we have 30, 32, 33, 35, 35, and 36. So all of the 30s I circled in green. And there we go. There's 30. Kind of making a mess. Do I have, okay, I have 32. 33. 35. 35. 36. Okay, and then the next one that I have is the 40s. And so let's see here. Here's my stem for the 40s. And then my leaves. I just have one, right? I just have 44. So that would go there, 44. And then they will give you a little key, okay? And you would have to include that too. You need to write your key. You just pick any of these that you want. Like you can say 35. You'd say 3/5 equals 35. Okay? If you wanted to do 44, if you wanted to do 32, 23, whatever. It doesn't matter. Okay? But you have to do a key. Sometimes that might mean 35,000, but they're not going to put all those zeros on it. They'll just put like the main base of the number. Okay. So copy all of this down. If you were just watching while I did that, then now's a good time to pause. Okay, then the big thing about the STAR test in these, because you're not going to have to create these, duh, on the STAR test, you're going to have to answer questions about them. Okay, so it says, where are most of the data values? How can you tell from looking at the stem and leaf plot? Okay, most of the data values are in the 30s. All right, so let's write that. Most of the data. This would be a good time to practice your penmanship, your cursive. Most of the data. That would be so cool if while I was walking around all you guys were writing in cursive. That would like blow my mind. Is in the, okay, I'm writing with a stylus. It makes it difficult. Most of the data is in the what? I can tell it's in the 30s, and because I lined up, the first number in each row, the second number, the third number, fourth number, made it pretty even. I took my time to line those up. I can easily tell. It's not because of my penmanship that this line is longer. It's because there are actually more digits there. Okay? Most of the data is in the, I already forgot, what was it, 30s? Yeah. Is in the 30s. Okay? How can you tell from looking? It has the longest, what would we call that? Row. Okay? Remember what I told you? I gave you a speech about paying attention and focusing on the teaching, not just surviving through it. Okay. Example 1 is more analyzing. Okay, it says a stem and leaf plot gives a picture of the distribution of a data set. You can find measures of center and spread from a stem and leaf plot. Okay, so we have to analyze these things, and because now you know how to read them, it'll be easy for you to analyze. For instance, it says here, Val's quiz scores are shown in the stem and leaf plot. Find the median and the mean. So when you're finding the median, you can just mark numbers out. Okay, let me show you something here. Look at your key. 3/2 means 32, and that's located right here. 3/2, that's 32. There are no numbers in the 40s the 50s or the what? The 60s. Okay? But they still put the 4, the 5, and the 6 there, kind of like placeholders. All right? But we don't include those when we're trying to find the median or the mean. All right, so let's find the median. I'm going to do it in purple. All right, so here's the smallest value, marking out the biggest. Okay, and then the next one, and I'm just going in order. If you want to do the like 1, 2, 3, 1, 2, 3, you can do that like this. 1, 2, 3, 1, 2, 3. All right, 1, 2, 1, 2, and then there's your median right there, which was 7. Okay. If we're going to find the mean, we have to add up the numbers, not just 2 plus 0 plus 5 plus 5. No, that's not what you do. You have to add up the numbers that they actually mean, like 32 plus, what's this mean? 70 plus, you can put them back together like that, 75 plus 75. Okay, the next is 82, 84, 84, 87, 87, 87, 90, 90, 93, ran out of space, 95, squeeze it up here, and 99. I'm going to write it really tiny there. Now I'm going to pause it while I add it. Okay, I'm not even going to do that because I know the sum is 1,230. And then there was 15 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's what I divide by, and your answer is 82. All right, now, the next question, possibility that you'd see that on your STAR test, which one better represents the data? Okay, so we had one number is 87. That was the median. And the mean was 82. Which one do you think, like you could say, these numbers are about 82, these numbers are about 87. Okay, well here's an explanation. Look at the shape of the distribution. The quiz score of 32 is much lower than the other scores, so it's an outlier. Remember, those outliers are the numbers that are way far away. If the outlier were not included, the mean score would be higher. That means this one, this 82, would be bigger. The median, 87, is a better representation. It's closer to everything. 82, it's brought down because of that 32. Okay? So more numbers are about 87 than are about 82. All right. So let's go down here, and you can just listen and watch. You don't need to take notes on any of this. The number of home runs a baseball player hit in each season he played is shown in the stem and leaf plot. How many seasons are included in the stem and leaf plot? Okay, let's count how many seasons. So it's the number of home runs he hit each season. So in one season he hit 0. In another season he hit just 5. The next season, I don't know. These are not the seasons in order. Just some other season, somewhere along the way, he hit 5. Probably when he was just starting out. Or maybe when he got really old and it was time to retire. He wouldn't give it up. All right. One season he's hit 7. Let's go down here to the teens. There was a couple of years that he had 10 home runs. This season here and this season here. What's the most number of home runs that he hit in a season? It was 44. That's probably when he was maybe in his 20s, and he's very strong and alert and very fresh. Not when he got old. I don't know. I'm just making that up. Okay, so number 2 says, how many seasons are included in the stem and leaf plot? So we need to count, really, each one of those numbers in the leaves. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there were 12 seasons that he played. And then it says, what's the least number of home runs the baseball player had in one season? Well, the poor thing didn't hit any one season. So the smallest, the least number is 0. Then it wants us to find the median and the mean and decide which one better represents the data. So let's find the median first. I like finding medians. They're just, I think they're easy to do. You're just marking numbers out. So there's that one. Okay, I marked out the biggest and the smallest. I'm going to go by twos. 1, 2, 1, 2, 1, 2, 1, 2. And then I have 2 numbers left over. So what's halfway between 8 and 9? Well, it's 8.5. So the median is 8.5. Okay, and then let's find the mean. I'm going to set up the numbers and then pause it. Okay, so one of the numbers is 0, and then I had 2 5s, 2 7s, an 8, and a 9. All right, that's all of the like less than the teens, the single digit numbers. All right, now we're in the teens. There's 10, there's 2 seasons that had 10, and then 17, and then 19. All right, we're not going to include the 20s because there was no 20s, and we're not going to include the 30s, but there was a 44. Okay, the total of all of those was 141, and we're going to divide it by however many seasons he had, which was 12. Okay, please do this with me. 141 divided by 12. Those of you who are really good at dividing, try to do it faster than me. And then those of you who need some support, do it with me. 12 does not go into 1. 12 goes into 14 one time. And so 1 times 12 is 12. You have 2 left over. Bring down the 1. 12 goes into 21 one time. 21 minus 12. 2 is too big to take from 1, so I have to borrow. 11 minus 2 is 9. So that is 11 so far. Decimal 0. Bring down the 0. 7. So the median is about 11. No. The mean is 11 and 7/10, more or less, somewhere around there. Okay, now, which measure better represents the data? And then justify your answer. Okay, so you can pick one, and your reason might be different than other people, and that's okay if you can give a good reason why. Okay, so let's see here. The median is 8.5. Okay, that would fall somewhere around over here. And the mean is 11, which would fall somewhere around over here. Okay, to me, first of all, neither one of them, because you can't have half of a home run. You can't have 7/10 of a home run. But this is going to be about 8 or 9. This is about 12. So which one best represents? I would have to say the one that's 8.5 that's over here, because there's more numbers clustered around that one than 11 and 7/10. Okay, I still don't sound like a robot, please. Using a histogram. And remember, you guys, if you want to go back and watch Dr. Berger, I'm sure he has very entertaining. He doesn't sound like a robot, right? A histogram is a bar graph, but at the bottom of the bar graph, you see intervals like this, 1 through 4, 5 through 8, 9 through 12, 13 through 16. The main thing that you have to remember is that your intervals can't be like this, 1 through 4, 4 through 8, 8 through 12, because these are overlapping. If you had something that came out to exactly 4, which one would you put it on? Another thing that you have to remember when you're coming up with your x-axis, your intervals, is that they have to have the same number of numbers in the group. So here we have 1, 2, 3, 4, that's 4 numbers. 5, 6, 7, 8, that's another group of 4. 9, 10, 11, 12, that's a group of 4. 13, 14, 15, 16, that is a group of 4. So the groups are the same size. Perfect. Okay, so this one says a bird watcher counts and records the number of birds at a bird feeder every morning at 9 o'clock for several days. It must be a little old lady. Make a histogram of the data. So when you are, when you are taking your STAR test, you do not have to draw one of these. This isn't that great. So you're not going to have to decide for yourself how big to make the intervals and from what to what. Are you going to label them? But you are going to have to pick probably the correct histograms. So when they're saying make a frequency table, they decided that this is what the intervals should be, and then they counted, okay, how many numbers from here are there between that include 1 through 4? All right, so I'm going to circle them in red, including 1 through 4. You see me circling these up here? 1 through 4. So that's 1, 2, 3, 4, 5, 6, 7, 8. And that goes to 8. How many numbers are there that are from 5 to 8? So there's 1, 2, 3, 4. Okay, so there's 4 numbers that fall from in that group from 5 to 8. 9 through 12. So there's 1, 9 through 12, 9 through 12, 9 through 12, 14 is too big. All right, so there's 2 of those. And then what's left over, just that 14. That falls in that one. There's only 1 of those. And now they want us to, it's like make a bar graph. And Clemente was saying that I make this sound too much. Okay, did anybody else hear that? I think I've done it maybe twice. The whole video, Clemente. All right, so this first interval is right here. There, I did it again. Sorry. This, and you just come over here and look, the graph goes all the way up to 8, whatever the frequency is. So the number that it goes up to depends on how many there are in that interval. All right. The question here on B says, what does the shape of the distribution tell you about the situation? Let's read this explanation right here. Oh, by the way, if you're wondering what you're supposed to be writing, you weren't. You didn't have to write anything on this one. I just wanted you to listen. The highest bars for the interval 1 through 4, which means that on more than half the days, 8 out of 15, the bird watcher saw only 1 through 4 birds at the feeder. The bars decrease in height, so it was more likely for the bird watcher to see fewer birds. Okay. So just a few days, did he see about 8 birds or less? Let's go down here. Kim has started rating each movie she sees using a scale of 1 to 10 on an online site. Here are her ratings so far. So a rating is like, I give it an 8. I give it a 9. Okay, if it was a 1, it probably wasn't a very good movie to Kim. And if it was a 10, it was probably a great movie to Kim. Make a histogram of the data. What does the shape of the distribution tell you about Kim's rating? they came up with your intervals for you. How nice! There's 2 numbers in each interval. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're going to first do the frequency table. So how many numbers are there that fall from 1 to 2? I'm going to circle them in green. Okay, so there's 1. What about 3 to 4? How many were there from 3 to 4? 3 to 4. Okay, I only saw 2. 5 to 6. Kind of like midway. She's probably like, it's okay. Kind of feeling about a movie. All right, there was 3 of those. And then from 7 to 8. 1, 2, 3, 4, 5, 6, 7 of those. And then from 9 to 10, that means it'd have to be like a super good movie. And she only saw 1, 2 super good movies. Okay, so now we're going to do the histogram. Right? How many were there? There was just 1. That's about halfway here. Oh, that's terrible. It's very hard to do this with a stylus. Pretend that's halfway. Okay. And then 3 to 4, there were 2 of those. Okay, pretend that goes up to exactly 2. From 5 to 6, there were 3 of those, so that's going to go up to halfway here. Okay. From 7 to 8, wow, there were 7 of those, so that's going to go up to halfway between 6 and 8. Oh, you think I would figure it out by the time I got to the end of my histogram. And then 9 through 10, there were 2 of those. Okay, so make a histogram in the data. What does the shape of it tell you about Kim's rating? It tells us there were more movies. Write it in cursive. Practice your cursive. There were more movies with a rating of Oh no, wait, those were the 5s and 6s. A rating of 7 to 8. All right, now you need to go back and do the dashboard lesson for 17.4.